Hello students, today we are going to do the next topic of the chapter sets, that is operation of sets. Operation on sets, right? So what are the different kinds of operations that we do in a set? First of all is like union of two sets. I'm writing few names here, then I'll describe each one. Union of sets. Number two, intersection of sets. Difference of sets. Then complement of a set. Right? Now let us start with union. Union of sets. How do we define it? A set which contains the elements of either of the sets or both the sets. Right? See, like if we have two sets A, I'm taking this as 1, 2, 3, 4, 5, 8, right? And B is 2, 4, 7, 9, and 10, right? Now here we have two sets. How we define union? Union of sets. First of all, the symbol for the union is U. A union B. Now union contains the elements of either of the sets or both the sets. What does that mean? Now you can see there are few elements which are common to both the sets. Right? Both the sets. That means 2 is there in both, 4 is there in both. Apart from that, this set has got different elements, this has got different elements. So what we do is we write all the elements once, like 1, 1, 3, 5, 8. These are the 4 elements which belong only to A. 7, 9, 10. These are the 3 elements which belong only to B. What about 2 and 4? Though they are present in both the sets, but they will be written once. So now what we have done is, we have taken all the elements, whether they are belonging only to one set or to the other one or to the both the ones. So this is the union of these two, A union B, which contains all the sets with all the elements which are either in A or in B or in both, right? Elements either in A or in B or in both. So this is the way we find union. You can write it this way or you can arrange them in ascending order because order of a set doesn't matter. So this is how we find union of sets. Right? Next is the intersection. Intersection of two sets. Right? Intersection of two sets is the set of elements common to both the sets, right? So like if I'm taking the same example, A, which is 1, 2, it was 1, 2, 3, 4, 5, 8. B is 2, 4, 7, 9, 10, right? So these are two sets, and if we have to write intersection, the symbol for the intersection is inverted U, A intersection B. So it is a set of the common elements only. 2 is common to both, 4 is common to both. So intersection is 2, 4, right? Now, the next one is difference of two sets. Now, what is the difference of two sets? Like we have A as 1, 2, 3, 4, 5. Difference of two sets, as the name denotes, difference of two sets is like A minus B. How can we write this? We can write A minus B as well as B minus A. So A minus B is set of elements in which elements of A are there which are not common with B, right? Common with B. See, now what are the elements like 1, 2, 3, 4, 5? What are the elements which are present in B common to A, like 2 and 4? These are the two elements. So if we write A minus B means elements which belong to A but not B, right? So A minus B is leave 2 and 4 behind, only write those elements which are in A but not B, right? Elements which are in A but not in B. So only A, or you can write this as only A, the common term used for this, only A. So you have to leave out the part which is common, intersection of B, you have to leave that, rest of the elements is A minus B. Now if I write B minus A, what is B minus A? Elements which are in B but not A. So leave those elements which are common with A. Here also 2 and 4 are common. So leave those two elements and write only those which are in B but not A. That is 6, 8 and 10. When you will be doing word problems, this is also called only B. Only B means elements which are exclusively present in the portion which are B, which is not shared by A, right? So this is the difference of two sets. When we are going to do Venn diagrams, we have a concept of universal set. Universal set. That means the set which we are considering for the question, the major set. Like if I write numbers from 1, 2, 3 up to 10, first 10 natural numbers. And if I have a set, this is the universal set. That means we can have further partitions of this set. Or this is the set which we are concerned about in the given question. And if we have a further set P, which has 2, 4, 6, 8, and 10. Now we have an operation which is called complement. Complement of a set. Complement of a set. Now what is that? If we are talking, if universal set is there and we have a set inside which is smaller to the universal set, then the P complement. Complement is written as this dash, or you can write P complement. Both are the right denotions for this. So P complement is set which contains elements from the universal set, except the elements of the set. Right? That means if P is a set 2, 4, 6, 8, 10, leaving like we just did in A minus B, we have to do A minus P. The elements which are there in universal set. This is the same as A minus B or B minus A. The only thing is this is the parent set. Universal set is the bigger set in which P is fully contained. So when we talk about the complement, that means the elements which are in universal set, except these ones. So what are those? These are even numbers, 2, 4, 6, 8, 10. So 1, 3, 5, 7, 9. So these are the elements which are complement of P. Complement means those are the elements which are present in the parent set or universal set, but they are not in P. Right? So these are the different operations on the set. We will be learning very much in detail when we are doing Venn diagrams. Right? So I hope you like this. So please contact Urban Pro. If you have any doubt or you want to take classes, so you can contact Urban Pro.